Good morning, good afternoon, everyone. Miss Mate and Miss Lavnika will be talking about common factors today. And we will be looking at some examples. First example is right here, 9x cubed minus 27x squared plus 3x. I can see there in the bracket monomial common factor. What does it mean?
Well, it means that we will find a term, monomial term, that is found in every single term in this trinomial, and that's why we will call it monomial common factor. So looking at three terms here, what I see looking at the coefficients, the common factor would be 3. But also looking at the variables, x cubed, x squared, and x, the common factor will be x. So putting it all together, the common monomial factor is 3x.
So basically you are telling me that 3x goes into all these three terms. In 9x cubed, yes it does. In negative 27x squared, yes. And in 3x, of course. Okay, so 3x is common, belongs to all three. I can factor it. Good. So let's see what's left.
So what's left will be, from the first term, 3x squared.
Let me think. Why 3x squared? 3 times 3 is 9. Yes, I understand. X times x squared is x cubed. I understand.
Yeah. From a second one, it will be negative 9x.
Negative 9x. Yes, I understand. 9 times 3 is 27. X times x is x squared. Yes, you're
and
right.
From the last one will be plus 1.
There you go.
So here we go. We factored the original trinomial using a monomial factor, common factor, and leaving a simplified trinomial in the brackets.
Okay, so nothing stops me to check my work. How would I check my work? What's the opposite of factoring?
Expanding.
Expanding. So what do I get here?
9x cubed.
Exactly as I wanted.
Negative 27x squared. And plus 3x.
Good. So yes, indeed, I checked. I'm okay. I don't need any help. I can do it by myself. Good. The next thing that we're going to do here, we're going to talk about binomial common factor. Binomial common factor. Okay, so what does it mean?
Well, it means that common factor will consist of two terms, and looking at this expression, I see that x minus 1 is a common factor in these two, in this expression.
Okay, so for these two terms, x minus 1 is common factor, so it means I can write it once. Then I open a bracket, and what's left from my first term after I factor x minus 1?
7x.
And from the second term after I factor...
Negative 14.
Okay, there you go. Am I done?
No, not yet, because looking at the second binomial, 7 and 14 have a common factor numerical value of 7. So we can factor out 7.
And let's see what's left.
X minus 2.
Good, but do we like this notation?
No. The rule is the number coefficients comes first, then binomial, first binomial, and the second binomial in whatever order.
Okay, so there you go. 7, the factor form of the expression given is 7x minus 1, x minus 2. Of course, nothing stops you to check your work. How are you going to check? By expanding. And we're going to leave this with you. Check by expanding.
Factor by grouping. That means that this is a polynomial that consists of 4 terms, and we will group these 4 terms into 2 different groups that will consist each 2 terms. So the smart idea would be to group the first 2 terms together, I think, and then second two terms together.
Now my next question is, does it necessarily need to be first two and last two, or
No.
there are other possibilities?
There are other possibilities as well.
Okay, so from the first two terms, what am I going to do with the first two terms?
Well, first two terms, the common factor is x squared.
Yes, it is.
And what's left is x minus 3 as a
Correct.
second factor.
Okay.
And from the second, the 3 is a common factor, and x minus 3 will be the second factor from a second group.
Oh, look what a nice surprise. What do I notice?
We have a binomial common factor now that we can factor out,
So it's gonna be x minus 3.
and the second factor will be x squared.
This is left
Plus
from my
3.
first group, and plus 3 is left from my second group.
Correct.
So there you go. I factored by grouping. Now, what's next? Always check by expanding. Now I was wondering, can we factor by grouping in a different way? Is there another possibility? For example, x cubed minus 3x squared plus 3x minus 9. What happens if I group first and third term and second and last? Do you think I can do that?
Sure, we can do that. So looking at the first and third term, the common factor is x. So what we have left is x squared plus 3. And then from a second green group, I can factor out negative 3. And what I'm left with is x squared plus 3.
X squared plus 3. Look how lucky we are.
Yes, indeed. Because now we have a binomial common factor that is x squared plus 3 that we can factor out from these expressions.
I forgot my equal signs.
Yes, that's important. And what's left? X minus 3 as a second factor.
Is this the same expression?
Absolutely. In a different order, we can put two factors together as a product in whatever order we like.
So I can write it as before, x
Yes.
plus 3x squared plus. There you go.
X minus 3.
X minus 3, you're absolutely right. X minus 3.
Yeah.
Good.
Okay.